Imagine tiny, shiny boxes, zooming around Earth, really fast, faster than any race car. What are these speedy specks? They are satellites, folks, our eyes and ears in the sky. They do more than you think, much more than just floating. They are quite the busy bees. You use them every single day, probably without even knowing it. When you check the weather forecast, thank a satellite for that. When you watch live TV from afar, a satellite is playing messenger, even finding the quickest route to your grandma's house. Yep, satellites help with that too. Some uses are quite serious, like helping ships navigate vast oceans, or scientists study climate change, understanding our amazing planet. But some uses are just fun, like beaming your favorite cat videos across the entire globe instantly. Satellites don't judge your choices, they just deliver the data. So these metal marvels are busy. They are not just space decorations. They are vital tools for modern life, connecting us in surprising ways, from saving lives in disasters to helping you win online games. Let's explore these sky-high helpers and see what makes them tick, or more accurately, what makes them orbit. How do these gadgets reach space? They don't just sprout wings and fly, no. They need a big push, a really, really big push. This push comes from rockets, giant tubes filled with fire. Okay, controlled explosions really, it's all very dramatic and loud. A true spectacle of power. Launching a satellite is tricky. It's not like throwing a baseball. You need incredible speed and precise aiming too. The rocket has to go up, but also sideways, very fast. This sideways speed is key. It's what keeps satellites from just falling back to Earth. Think of it like this. If you throw a ball hard, it goes far before it lands. Now imagine throwing it so hard, and from so high up, that as it falls, Earth curves away beneath it at the same rate. That's the basic idea here, a constant state of falling but missing. So these powerful rockets carry our precious satellites upwards, through the thick atmosphere. Higher and higher they climb, then, at just the right moment, the satellite is released, pushed out into the void, to begin its long journey, orbiting our big blue marble. Once a satellite is in space, why doesn't it just float away? Or come crashing back down? It's all about balance, you see, a delicate cosmic dance. Gravity plays a big part, that force that keeps your feet firmly planted on the ground. It's pulling on satellites too, but satellites are also moving very, very fast. Sideways. Remember that from the launch? This speed creates an outward fling, some call it centrifugal force. Though physicists might prefer inertia, it's like swinging a bucket of water. Swing it fast enough overhead and the water stays in. Magic. So, gravity pulls the satellite down. But its high speed wants to make it fly off in a straight line. These two forces are in a tug of war. When they are perfectly balanced, the satellite stays in orbit. It's constantly falling towards Earth. But it's also constantly moving sideways fast enough to miss. This is what we call an orbit. A path a satellite follows, around a planet or a star. Different satellites orbit at different heights and speeds. Some are relatively close, others are way out there. Each orbit is carefully chosen, depending on the satellite's job. Ever used a map on your phone to find a new coffee shop or to avoid getting lost in a strange part of town? Chances are you use GPS, Global Positioning System. It sounds very grand, doesn't it? And it truly is quite magical. A gift from our satellite friends. GPS is a network of satellites, at least 24 of them, usually more. They are orbiting Earth way up high, about 20,000 kilometers or 12,500 miles above us. That's a long way to shout. Each satellite knows exactly where it is and it constantly broadcasts a signal. A tiny "hello, I'm here" message. Your phone or your car's GPS device is a receiver. It listens for these satellite signals. When it picks up a signal, it knows how far away that particular satellite is. It does this by measuring how long the signal took to arrive. Light speed is fast, but measurable. But knowing your distance from one satellite isn't enough. That just tells you you're on a giant imaginary sphere. Around that one satellite, not very helpful for finding pizza. You need more information, at least 3 satellites, ideally 4, to really pinpoint your location. Section 5, Pinpoint Precision, how GPS actually works. So your GPS device talks to satellites not with words but with timing. Each satellite sends out a signal. This signal says, "I am satellite X. The time I sent this was Y." Your device gets this message. It notes the time it arrived. The difference is travel time. Simple math really, for a computer. Knowing travel time, and knowing that radio waves travel at light speed, your device calculates distance. Distance equals speed of light times travel time, so now it knows. I am Z miles from satellite X. This creates an imaginary sphere. You are somewhere on its surface. Still a big area, but progress. Then your device listens to another satellite. Satellite Q, let's call it. It does the same calculation. Now you have two spheres. These two spheres will intersect, forming a circle where they meet. You are somewhere on that circle, getting closer to finding that pizza. But a circle is still too vague. So your device needs a third satellite, satellite R perhaps. Another calculation, another sphere. This third sphere intersects that circle at 2 points. Usually one point is obviously wrong, like it's in outer space or deep inside the Earth. The other point is you. Bingo! A fourth satellite confirms and refines. Section 6. Cosmic Weatherman Satellites Predicting Storms and Sunshine. Ever wondered how weather forecasters know a big storm is coming? Or if it's safe for a picnic? They aren't just guessing, usually. They have eyes in the sky. Yes, our good friends, the satellites. Weather satellites are like cosmic spies. They watch our planet's atmosphere and report back what they see. These satellites carry special cameras and sensors too. They can see clouds forming day and night, which is handy. They can measure temperatures of the land, the sea, and the air. They track wind patterns and even measure moisture levels, all from hundreds or thousands of miles up. This information is super important. It helps meteorologists create models, computer programs that predict weather. The more data, the better the model. The better the model, the better the forecast for your weekend. Satellites provide a constant stream of fresh atmospheric data from all over the globe, so when you see those swirling cloud patterns on the news, that's often a satellite view. They help us see the big picture, how weather systems move and develop. They warn us about hurricanes, tornadoes, blizzards, and floods, giving people time to prepare. Satellites are lifesavers, really. Section 7. Chatting across continents, satellites as global messengers. Remember old movies? Where making an international call was a huge, crackly deal, or took ages to connect. Well, satellites changed all that. They act like giant mirrors in space, bouncing signals from one point on Earth to another, making the world feel smaller. Communication satellites often sit in a special orbit called geostationary orbit. It's about 35,786 kilometers high. At this height, a satellite orbits at the same speed Earth spins, so it seems to hover over one spot on the ground, like a fixed relay tower, but in space. This is perfect for communication. A TV station can send a signal up to the satellite. The satellite catches it, amplifies it, then beams it back down to a huge area on Earth, covering entire continents sometimes. This is how live sports events reach your screen from far away. It's not just TV either. Satellites help with phone calls, especially in remote areas where laying cables is impossible or too expensive. They provide internet access too, connecting isolated communities and helping ships and planes stay in touch while on the move. They are the ultimate long-distance carriers. Section 8. Oops! Space junk and other orbital headaches. Life as a satellite isn't all smooth sailing or orbiting. Space can be a tough neighborhood. For one thing, satellites get old. Like any machine, parts wear out. Solar panels degrade over time. Batteries lose their charge. Eventually they might stop working, becoming silent, drifting metal. Then there's the problem of space junk. This isn't leftover pizza crusts. It's old, dead satellites, bits of rockets left behind, fragments from accidental collisions. There's a lot of this stuff up there, millions of pieces, big and small, whizzing around at incredible speeds. Faster than a speeding bullet. Even a tiny piece of debris can cause huge damage if it hits a working satellite. It's like a cosmic car crash. Scientists track the bigger pieces, and sometimes satellites have to maneuver out of the way, a little space dodgeball. But it's a growing concern. And sometimes things just go wrong. A solar flare from the sun can disrupt electronics, software glitches can happen, or a tiny meteorite might strike. Keeping these high-tech helpers running smoothly is a challenge. Engineers on Earth work hard to monitor and maintain them, but space is unforgiving. Section 9. Our silent partners in the sky, why we can't live without them. So, there you have it. Satellites are pretty amazing, right? These orbiting wonders do so much. They are more than just gadgets. They are an essential part of our modern global society, quietly working above our heads, making our lives easier, safer, and definitely more connected. Think about a day without them. No GPS to guide your car. Weather forecasts would be guesswork. International calls? Forget it. Live news from across the world? Nope. Credit card payments might fail. Disaster relief would be harder. It's a bit scary to imagine. We rely on them so much. From understanding our universe better to exploring distant planets, satellites are our cosmic explorers. They monitor our planet's health, tracking deforestation and ice melt, helping us be better stewards. They are tools of science, of communication, of discovery, and sometimes of cat video delivery. So next time you look up at the night sky, remember them, our silent, tireless partners whizzing through the darkness. They are a testament to human ingenuity, our curiosity, our drive to explore, and our need to connect. Satellites are truly out of this world, but they make our world work.